All right, guys. So now we're going to get into constructing lines and angles. This one, it isn't that bad with GeoGebra, but once we start getting into the more complicated parts of it, it does kind of build on itself. Like when it starts talking about perpendicular lines, how to make a perpendicular line, how to make a parallel line, it starts getting a lot harder on GeoGebra. And this is like kind of the beginning of once we start getting into doing more things on GeoGebra. They were nice on Unit 1 with the activity, but I think from now on, all of the unit activities or all the unit and course activities are going to be on GeoGebra. So this is a really important tutorial. So let's get into this one. So our goals for this one is going to be make formal geometric constructions with a variety of tools and methods. So usually we use tools like these. We use compasses or protractors. Protractors are these things that measure the angles, or these angle rulers. Usually they're 45, 45, 90 triangles or 30, 60, 90 triangles, and that's referring to the angles of the triangle. In this class, because it's online, we're mainly going to use GeoGebra. So copy and pasting line segments. This is a lot easier with GeoGebra, so we don't have to use a compass. We don't have to use a ruler, pencils, erasers. It is a little weird to understand when we get used to it. So when we're talking about what are the steps of copying an angle with a compass and a straight edge. So if we go into here, the way we usually do it is we make a straight line, and then with a compass, we're kind of. Why are they using a compass instead of a protractor? That's really weird. We can watch the videos, but essentially, let me kind of try to do it because I don't want to really go into watching the video. When we're copying an angle, it's the idea of. I would honestly use a protractor. I don't know why they would ever have you use a compass instead of a protractor. So if you're copying an angle, let's say we have this line, we would do another line here. And if we want to copy it, what we would do is we would extend the line. So we would get our ruler, extend the line. We would use like a little protractor to measure how far that is. I know that's a terrible protractor, but we would measure it. And then what we would do over here is we would make a really long line, use our protractor to measure it. We make a little dot like over here. We get rid of our protractor. And then we use another ruler to do this. So I don't know why they want you to do it with a compass and a straight edge. In real life, you wouldn't do this. You would use a protractor. So you can mention that here. Let me type that in. So I would use a protractor to measure an extended line of the angle. And the reason why I say you have to measure an extended, is because sometimes, let's say usually your protractor is going to be really big. So let's say your angle is like this small, but your protractor is like this. So you put your little dot right here where it matches up right in the center. And it's like, well, I can't measure it. This protractor is too big. So you would have to use a ruler to extend the lines. So I guess I should do that. Use a straight edge. They call it a straight edge. A straight edge is basically just a ruler without the markings. What happened here? My thing. closed for some reason. What in the world? That's so random. Yeah, I just closed. All right. Sorry about that, guys. I don't know why that happened. Recently closed. All right. Now I have to type the whole thing over again. All right. So use a ruler. I say ruler. They like to use the word straight edge. Use a ruler to extend lines of angle. Use a protractor to measure angle. Use straight edge. So we're going to use the straight edge or the ruler, whatever you want to call it. Use straight edge to make a line. Use protractor to copy the measured angle. So that's all we're doing. We're just kind of using a straight edge. The compass, you could do it. To me, it's always kind of been weird using a compass to do it. It feels like it's a lot more work, in my opinion, because the way you do it is you kind of, with a compass, you kind of like measure out the compass, the length of it. You use a compass to kind of go like this, and it's just a lot of work. I've never done it. I've taken architecture and engineering classes, and they use a protractor. So I feel like this is an outdated way of doing it with a compass. There's other things we use compasses for, but to copy an angle to me doesn't make any sense. Every teacher I've ever seen does it that way. So methods you saw to employ a compass and straight edge. Now we'll use modern technology. So again, to me, you're going to be using a protractor. If you're using the old way of doing it, you're not going to be using a compass to measure and copy an angle. So now we're going to do it with Geogebra. So with Geogebra, first thing we're going to do is measure AB. So first of all, let's get into our copy and line segments. So they want us to measure AB. The way we do that, we go over to this little tool right here. This is our measuring tool. This 1, 2, 3, 4, 5, 6, 7, 8. This one is how we're going to measure tools. It's also how we can create an angle that already has the sides that we have measured. But I'm going to measure this distance, and I can do two things. I can click A to B, or I can just click the line segment, and it just gives me the length. So the length is 5. So now we're going to create another line segment with the same length. Measure CB to verify it. Take a screenshot. So there's two ways I can do this. I can either go to create a line segment, and I'm going to try to guess how far 5 is, which is hard, or easier way, segment with given lengths. I can click this, and I'm just going to say 5, and it'll give me a 5. Now, no matter what I do, this will never get closer to it. We'll get into why this makes a circle later. That's actually a very important thing that we'll learn later on, but this is never going to get any closer. Even though I'm moving the mouse closer, it's always going to stay at 5. And it wants me to measure it, so I'm going to click my tool, click this. It's 5. I can take my screenshot. So you can export the image, download this or whatever. So you export it, download it, upload it. I don't think I've shown you guys how to do this, but so let's say I download it. So I'm going to download it, and then I go over here. Oops, wrong one. Sorry. Insert image. I can drag it from here and just put into here. And it's supposed to, there we go. And we can do that. Also, I would like you guys to also give me the link. So you guys can also just save this and copy the link. That way I can see other things. Sometimes I can't see everything you've done. So I do like having both. But does that make sense how to do the image a lot faster instead of taking a screenshot? Okay, cool. And I do want to see your image there too, but I think this is easier than taking a screenshot is to export it. I actually discovered this way later on how to export the image when a teacher was like, I don't like having to screenshot it and do all this work. And I'm like, you can just click this button right here. But there. So that's all they wanted us to do. They just wanted us to copy the side lengths. That's it. So now we're going to copy angles. So first they want us to measure the angle. So we're going to go here. They want us to measure this angle. So when we go here, we're going to measure angle. So we just click angle. Click the starting points, the middle point, and the end point of the angle we want to measure. Make sure you go counterclockwise, which is this way. That way is counterclockwise. The reason being is, let's say you accidentally go clockwise, which would be this way. Let me show you what happens if you measure it the wrong way. I think I've shown you guys, but I just want to be sure. It's going to measure this outside angle. So you always want to go clockwise, otherwise you're going to be, or counterclockwise, otherwise you're going to be measuring the wrong way. So always remember, think of a clock. If you can picture the 12, then it's 1, 2, 3. You want to go the opposite way when you're measuring your angles. All right, so we're going to do this. And then create another angle with the measure of this, verify this. So Geogebra actually gives us a really cool tool to be able to copy it really easily. What we're going to do, we're going to click this, angle with given size. So the easiest way to do this is first have a line segment ready. Then you are going to go angle with given size. I'm going to click E because I want the E to match up with the A. Oops, my bad. D to E. Why isn't this working? Okay. I don't know why that wasn't working. Sometimes GeoGebra's fidgety, guys. I don't know why it doesn't work sometimes, but it just doesn't. So now it's going to ask me the angle that I want. So I'm going to say 51.34. Delete that. And I want this going counterclockwise. If I said clockwise, it would go this way. I want it counterclockwise so I can copy it. It doesn't matter how you guys do it, just as long as the angle's the same, because they don't care the orientation or anything. I just want it to look the same. I'm going to do that. Now this gives me a dot at the same length. So what I would have to do would be to connect this line. And if I wanted the same length, I would have to use a compass. In this case, it's an actual circle, but it just wanted me to copy the angle. It didn't care about how long that angle was. So for right now, this is good enough. And see how this doesn't extend all the way here? If you want that to happen, what we're going to do is we're going to use ray instead of a line. If you use a ray, it only does it in one direction. So the difference between a line and a ray is a line goes both directions, a ray goes one direction. And then it wants us to measure the angle. So we have that measured already because using the tool measures it for us. And we just need to take a screenshot. So go to export image. download this. I wonder if it says it should copy it to the board. Let me see. Export image, right click, copy image. I don't know if they fixed this on Edmentum. Before you could paste image, and it's not working. So since that's not working, you're gonna have to download it. Image. Let me get rid of this. There we go. And I can drag the angle into here. Let's say this doesn't pop up for you guys. What you can do is go into your files. Depending on where it goes, my computer says it automatically goes to downloads. So I can just click it there. And that's another way of uploading the image. And again, give me the link just to be a little more specific. Did not copy the link. Oh, I didn't copy it. And you're all good. Does that make sense how to copy an angle, guys? Cool. And then just talk about like things that you learned and stuff in the self-evaluations. This is like like I said, treat self-evaluations like a time to be like, what did I understand, what I did not understand. Treat it like a self-reflection more than a self-evaluation. You know, this should be, don't just be like five, blah, blah, blah. This is a good time to think, to start asking yourself, what did I learn? What didn't I learn? All right, so now we're gonna do how to bisect an angle. So when you're bisecting an angle, you want to cut that angle in half. Again, I'm not the best at constructions, so you're probably going to want to watch this video if you want to like see exactly how to copy this. Again, I'm not going to go through videos, but right here you can see how they're doing it with the protractor. So they're doing this, they're doing that. Usually I just use a big circle to bisect it, to be honest. And then they do this, which allows you to kind of make these little intersections. I'll cut it right in half. I'll explain what all of this is later. This will make it a perfect angle in the middle. So if I want to bisect this angle using modern tools, so if I want to do it with a compass, I would make a make marks with compass at a set point on both lines. So that's where you saw the compass cutting it on both lines. And then from there, from those marks, make two intersecting marks. So that's what I mean by intersecting marks is I mean two marks that are kind of like crossing each other. And again, if you want to review this back on the YouTube, you can, or you can always just go to the tutorial and look at that again and explain this in your own words and make those two intersecting marks. Then use straight edge to line it up. And I'm actually glad we're doing this exercise because this will be like a good reason on, so you can see how they describe it. They obviously describe it a lot better. You can use these words or you can use your own words like I did, as long as it kind of makes sense. So now we're going to use modern tools to do this. All right, so we're going to bisect an angle. So this one says create an angle that's halfway from this. So let's do our bisect angle thing. So let's say I wanted to bisect this angle. You'll notice that the easiest way of doing it, and it's cheating to be honest, is what we can do is we can measure this angle. Oops, hold up. Measure this angle going counterclockwise. Oh, look, it's 51.34. Now what I'm going to do is I'm going to open up a tab on Google, my calculator, 51.34, 1.34, and I'm going to divide this by 2, 25.67. So, oops, let me close. So if I want to bisect this, I would say I want to do an angle with a given size from here to here, and you have to do it at the A because you want to cut that in half. Now, you're going to do it at 25.67. So I'm going to do this at 25.67. I want it counterclockwise because if I do it clockwise, it's not going to bisect it. There, now we have an angle that's perfectly bisected. I'm going to do it as a ray because I don't want it to go on the other side. So that's one way of doing it. If you want to do it the way you're supposed to do it, I think this way is honestly better. It's a little more accurate. But if you want to do it the way like engineers do it when they don't have the tools to measure this perfectly, what you would do is you would grab a compass, quote unquote, which in this case would be a circle. You could use a compass. It is so much harder. Watch. I can't even, to be honest, it's honestly kind of pointless. What I do is I just use the center. I make this circle. Now you have marks from here and here, right? From here, what you're gonna do is you are going to make another circle. Just give it a given radius because you do want these to be the same. So I'm gonna do a circle with a radius of, I don't know, 2 or something. And then from here, I want a radius with 2. Now these two are intersecting right there. They also intersect here. So what you would do is make a point, and then from here, you just make your ray to your point, or even this point right here. Uh, Boom, it'll be the same line. Let's say you don't want to see all of these circles. You are going to get rid of them. So you go over here to conics, hide your circles, and you have that. So let me do the undo so you can see how similar these angles are to each other. Oops, I guess it doesn't let me redo it because I didn't undo. Those are both two ways to make a circle. Does that make sense, guys? Yes, no, maybe? Okay. So that's how they would want you to do it. Again, I think if we're already using these tools, it is useful to know how to do it, but to be honest, it's honestly just I just like doing this better. I think it's more efficient. It's a more efficient use of your time. Boom. Doing the compass, I honestly haven't even used this. The reason being is it's just awkward. It makes more sense to me to just use a circle. If you're ever going to use a compass, just use the circle thing. And you just ignore anything that you don't need. So if it ever says like use a compass, I recommend just making a circle. It's more complete. You don't have to worry about making your length and everything. All right. So again, you're going to export the image and upload it and give the link. Like I said, give the link. That way you can prove like if anyone ever doubts you, it's like, hey, this is the exact same picture so and so used. It's like, no, here's my link. That's mine. All right, so now open it again. We'll use modern technology to replicate The original one? Okay. So they literally wanted you to do it with the circle. So this one, are they going to make it create two circles, blah, 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 blah. Oh, so this one, they do want you to use it. This one, blah, blah. Create an image using array verifying the points, take a screenshot. So this one you can use with measuring. This one, they are going to want you to use the circles. So if you want it, so you have to use the circles for this other one. So the first one, use what I did. Cut it in half and all that. Fine, perfectly fine. And then for the other one, you're going to have to do the circle one. So let me undo this until, no, it's not letting me do it anymore. Well, you guys can rewatch the video on how to do the circles one. So this one, you have to do the circles. This one, like I said, I don't care. Just do it by like cutting it in half and verifying it. Measure two angles to verify that it's been bisected. So if you want to measure the angles, all you literally have to do is go here, angle, and measure it counterclockwise. And that's all you're doing to verify that it's halfway. And let's say you guys don't like that you can't see it, just grab this and pull it out. That'll let you see all of it. If you guys need help with constructions, let me know. We can always do an appointment together to kind of work on it together, because these are hard. That's why. Do you guys like the videos? That way you can always go back and watch them. Like, have those been helping out? Okay. All right. So now we want to make perpendicular lines. So the way you normally make a perpendicular line, I usually use perpendicular bisector, to be honest, is, let me see if they show it this way, because this is how I used to do it back in my engineering class, is you have to make a circle. You want to make a circle that's more than halfway through. And then you're going to make these little points here, and you make these little points over here. And then you make the line straight through. So that's how you would do it back in the day. So what you would do here is, I say make a circle that that has a radius bigger than half the line. I'm basically making a circle. Like, let's say I have a line. Where's my pen? I haven't been using my pen because it's been all GeoGebra. And my halfway point's here. I'm going to want to make a circle that's more than the halfway point, because when I do a circle over here that's more than a halfway point, it gives me these two crossing areas. So make a circle that's bigger than half the line. Let me use the correct term here. Line segment. A line goes on forever. A line segment has a starting and a stop point. Do this for both sides. Make a line go through where they intersect. So we're just going to make a line go through where those two circles cross each other. All right. So now we're going to use modern tools to stimulate it. So this first activity, create a perpendicular bisector, identify the result. Here, take a screenshot, and then create another line passing through it, verify it, create another line perpendicular to that passing through it, create another. I want to see what they're doing here. Create another line perpendicular to that, take a screenshot, use modern technology. So these are actually really simple to do. So it looks like it wants you to do the easy way, and then it wants you to do the hard way at the end. Don't know why it wants you to do that, but whatever. So first things first, they want us to create a perpendicular bisector. So let me show you how to do it the easy way. Apparently Edmentum wants you to do it the easy way first. I want to create a perpendicular bisector, right? Yes. So what I would do is I would go to here, click perpendicular bisector, and I want to bisect A and B. Notice how if I go a little bit before A, it changes. The reason for this is because, and if I rotate, obviously it rotates, is because a perpendicular bisector literally means cut in half. So as I get closer to A, it moves closer to A. So I want the perpendicular bisector here. Boom. Simple. You just click that, done. Then you export your image, share your link. For this next one, it wants us to create another line perpendicular, but goes through point C. So this one, what you're going to do, you're going to open up another activity for the perpendicular lines. And you're going to go here and you're going to do perpendicular line, not perpendicular bisector. You do not want to cut this in half. You click the line. So does it show it down here? What you're supposed to do is you click the line and you click the point you want it to go through. So I want to go through point C. So I'm going to click point C. Boom. This line is perpendicular to that. Measure the angle. Oh, one thing I forgot to do was measure the angle. Oh, this one didn't even ask you to measure the angle. Oh, you had to verify the points. So if you have to verify this, what you do is you make a point here, right at the center, and you want to measure it. So you go to here for our measuring tools, measure from A to E, and then we're going to measure from E to B. Boom, they're equal. Then you would upload it. I'm sorry. And then from this one, we want to make sure that this is perpendicular. So what I'm going to do is I'm going to make a random point on this line. I need a point on this line because otherwise I can't measure it. Then I would measure the angle. I need to go counterclockwise, so this way. So I go from B to C to E. It's a perpendicular line. Now I can export my image and share the link. Am I going too fast, guys, or is it a good pace? Let me know in the chat if you think I'm going too fast for these. You guys good? So this next part, so we got that, copy and paste it here. So I did that. I did this part for part C and I verified it by measuring the 90 degree, this one, the 90 degrees. So after you export it and everything, copy it down. And now create another line going through point D. This one's actually not that bad. It's actually really similar to the other one, almost exactly the same. What you would do here is you would go perpendicular line from here. Oh, you would just click the line you want it perpendicular to and click the point you want it perpendicular to. And why isn't this working? Line that's perpendicular, click this point, boom, same thing. The only difference is you're going up here instead of down here. All right, so now that you have this, you're gonna export the image like you did before, download it, export it, copy it from here if you want. If you don't want these here, just click cancel, or I'm sorry. Oh, I guess you can't get rid of these. Make sure you name them really well, because if you don't name them, it's going to be a little hard to tell. So right here where it asks you where to name them, also pay attention to where you're saving them if you need to go to them later. I'm saving them to my downloads. All right, copy and paste that. Same thing with your link. So do the image and the link. It just makes it better. All right. So, and that was this one. So now we got the easy ones out of the way. Now it wants us to do the hard way. We're going to do a bisector. So the way we would do this, mark points EF, we have to follow these exactly how they say it. So let me get into this. So here's our line. It wants us to make a circle that's greater than half the length. So what we're going to do here is we're going to do circle, group, point. So we're going to click here. We want it to be greater than halfway. So we can literally do it like this if we want. It's overkill, but it's fine. I'm going to go like about here. Then what I'm going to do here is it doesn't matter how big I make this circle, just as long as it's bigger than halfway. Oh, it's supposed to be the same length. Oops, sorry. I haven't done this way in a while because GeoGebra makes it so easy to make a perpendicular bisector. So I'm gonna do circle with given radius. I'm sorry, guys. So circle with given radius. I'm gonna say about 5 is more than halfway. 5 looks like it's more than halfway, so we're good. And I'm gonna do it from here, and I'm also gonna do it 5. It has to be the same length, otherwise it's not a perpendicular bisector. Make your dots. And in case you guys are wondering, how do I know if it's more than halfway? If your circles don't intersect, that's a good hint that it's not halfway. So let me show you. Let's say I only did 2, for example. Let's say I clicked here and I'm like 2. First of all, that doesn't even look like halfway. But if I did it over here and I did 2, they're not even touching each other. So that's a good hint that you're not doing it halfway. Does that make sense? From here, make your points. From here, make your line. So we're just going to click here, click our line, click both of those points that we made. Boom. Now it wants us to prove that this is a perpendicular bisector. Sorry, I haven't been following the directions. So we're going to do that, make another circle with the same radius. That's the step that I forgot to do. Label the points E and F, connect those points. We're going to make another point called G. So if we literally tap this in, it'll name it G for, ooh, why is it naming it H? Oh, I made this point over here. That's why. It doesn't matter just as long as you remember that it's not called G, it's called H. And then um, it wants us to measure the angle and measure the lengths. So go to measure lengths, A to H, boom. B to H. Ooh, these aren't equal. Something happened here. All right, so that's a good hint that I messed something up somewhere. I might not have clicked the exact point of A and B. Let me try this again. 5. Make sure I click B. Click 5. Make sure it's right here. To make sure that it is the intersection, you want to see it black. If it's not black, that means you can move this. See how I can't move this? I'm clicking on it and I can't move it. That means it's the point of intersection. Unless the circles move, that point's not going to move. Okay. And then I'm going to make a line from here to here. One good thing is that this makes it so this point now is point G. Measure the distance. Measure the distance. There we go. Cool. So I know this bisects it. I know it cuts it in half. Let's see if it's perpendicular now. That's actually the next step. It wants us to measure the angle to see if it's perpendicular. So from here, we're going to go to our measuring tools, go to angle, here, 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 perfectly 90 degrees. You could have also gone here, here, and F. Either way, you're good on this one. So again, copy the thing, copy the image, copy the link. So do both image and link. All right. How do the measures that record verify EF perpendicular bisector? So how do the measurements of the core this recorded? How do they measure? So the lengths of the line segments are equal and the angle is 90 degrees. That's all it wants us to say about this. How are you guys doing there? You guys awake? You guys sleepy too? Okay. Sometimes I get worried when you guys are quiet. I'm like, did I make them go to sleep? All right. So let me. What is going on here? Okay. That was weird. Oh, I think I clicked the camera. All right. So let's wait for this to load. Oh my gosh, we're not even halfway, and this. All right. So it's going to go through how to verify it. We already know that. We've already done this. This is actually a really cool tool for making 90-degree triangles. So that's why it's talking about doing this. This actually would, depending on the length, make your triangles perfect 90 degrees. So you get this perfect parallelogram going on here. We'll go over those later. And it's going to talk about the proofs. So in order to prove that these are perfect line segments, we're going to explain our steps. So first we locate the points, then we draw these line segments. We know that these are 90 degrees because of how we bisected it. Here we're going to locate the points, draw the lines. Because AP is equal to AQ and AB or PB is equal to this, we can say that the distances are the same. Each of the distances drawn have the same length with a compass. So now that we said that they have the same length with the compass, we can say that this is an isosceles triangle. So this top part, isosceles, because this and this are equal. Why is that? Well, because these two lengths are the same. Blah, blah, blah. So then we're going to say that angle this and this are the same. So where'd my pen go? There it is. So it's saying that this angle and this angle are the same. How come? Why are these two angles congruent? Well, that's because when you have an isosceles triangle, these angles, they call these the base angles. These base angles have to be congruent. The reason why that is because since they have the same lengths, that means the angle has to be the same. Angles are this idea of ratios. Your this over this, or I'm sorry, your kind of like your slope. Think of an angle kind of like a slope from the horizontal line. So if you want this length to be the same, then obviously your slope has to be the same. So why are these triangles congruent? Why are these triangles congruent to each other? It's like, oh, because all of the sides are equal to each other. If all the sides are equal, then obviously the triangle is congruent to each other. So here's another example of a proof. And then it goes into more detail about this. Well, if this is congruent to this, then So if we can say that these two angles are congruent to each other, then we can say that this entire angle is congruent to that angle. And from this point on, we can say that, which triangles are we talking about? APQ, APQ, this top triangle is equal to this bottom triangle, which is what I said earlier. It just GeoGebra, Edmonton kind of proves it a little slower. If it doesn't make sense, guys, again, I invite you to go back and read it. If you guys need further explanation from me, again, feel free to make an appointment. In the earlier part of the proof, we're saying this. Now we say that they're the same things. So it's just saying that if these two triangles are isosceles and these angles are congruent, and that part. So it's just reviewing the proof. So this is just explaining it in more detail. So because we said that these two triangles are congruent, we can say that these triangles are congruent. And if we cut these down the middle, why are we able to cut it down the middle? Because we're saying that this triangle is equal to this triangle, which they do, where is it? APB, APB. So this half of this triangle, this triangle is equal to this triangle. Sorry, I know the drawing's bad, but I just kind of wanted to illustrate it a little bit more. So if these two triangles are equal, then this angle has to be equal to this angle. Well, this angle also has to be equal to this angle. So they're just kind of going through the proofs and the reasoning behind it. Sorry, I know I went through the proofs really fast, but I just want to get through this so that way you guys can, in case we have another, do we have another activity? Here they're going to go through the explanations of everything. So if these two triangles are equal, then these have to be equal because of corresponding parts of congruent triangles. So basically when it says a triangle is congruent to each other, all the angles have to be equal, all the sides have to be equal. That's a big proof that we're going to do here. So this is going to do what's called the angle side angle congruence test. And we're going to go into these congruent tests a lot faster. These are just kind of a preview of it. Faster. We're going to go into them in more detail. So just pay attention to these tests, the side angle, the angle side angle test of congruence. And there's another one. They're not, angle side angle congruency tests, and they're using that to prove that the triangles are congruent again. 360 degrees. These are just proofs on why they're 90 degrees. Sorry, I know I should go into more detail, but I want to. These are things that you can always review on your own, but these are just examples of proofs. I do recommend going through them so you can understand more about how to do a proof, because proofs are going to be a huge part of this class. How to make a parallel line. So again, we're going to watch this little thing. I thought these were videos at first, but I'm going to run it. So first you make your random line there. You're going to use a circle here, another circle with the same radius there. You're going to extend that circle, make that radius the same, and this makes a parallel line. So to kind of explain to you what's happening here is what they're doing is they're making the distance from here to here the same. So the distance from here to over here is the same. And then they want this distance to be congruent here. So from here to here, they're going to make that distance same. I'll show you how to do it using the translate thing, or translate. Translate. How to translate it over. It makes it really easy. You'll see what I mean in a bit. So we're going from here to here, and we're going to copy that distance. So, let me go to the next slide. So first, make a point outside of the line. Draw a line from this point intersecting, and it doesn't even have to be like a nice intersection. It can be any type of intersecting with the line PQ. PQ is the line that we're talking about here. Okay, from here, make a circle from, we're going to make a circle from here to any distance. Make a circle of any distance, point of intersection. So what I mean by that is just where the lines cross, make a circle, and then do this at the point you made. So we're going to do that from the point that we made over here. Measure the distance and copy, measure the distance from these points and use it for another circle. And I'll get to that right now. So I know my instructions are very weird. You guys can always look at the sample answer for more details, but I don't like seeing these steps, and I don't like how fancy the words are. They're way too specific. Use your own language. You can look at your sample answer, but don't copy it. It won't make any sense if you copy it. So I'm gonna do this the hard way first because you guys should be able to do. Oh, okay, cool. The hard way isn't that far into it. So I'm gonna do this the hard way first because we only have we do. I'm trying to rush through this. I'm sorry I'm going so fast, guys. All right. So let's say I want to do this the hard way. So if I want to do this the hard way, I'm going to pick a random point. Then what I'm going to do is I'm going to make a line from here to this any way I want. Oh, I should have made that on the point. Here to anywhere on here, right? Cool. So that's how I did this first part. Now what I'm going to do is I'm going to make a random. Why do I have so many of these open? There we go. I'm going to make a random circle. I'm going to use with given radius because I want it to be the same circle. So I'm going to make it with a radius of 2. And then I'm going to do it from here, also with a radius of 2. So that gives me this point here. So now what I want to do is I want to measure this line right here, right? From here to, oops. Let me make the point so it's better. From here to here. I'm going to measure the segment. And to make this easier for me, so I don't have to like really struggle with it, instead of using like their little trick where it's like, oh, I'm just going to copy this and remember what the thing is, I'm going to do this. I'm going to make a circle from here to here, I'm going to translate this circle so that, so I go here, I'm going to translate it. I'm going to grab the circle and I'm going to drag it right here. See what I'm doing? I'm moving it so the circle touches this point right here. Oh, actually, oh, that's not going to work. I'm sorry. I tried to get fancy with it by copying the circle method, guys, and that's not going to work. The easiest way to do this, to be honest, is to translate this point. I want it to be fancy to kind of simulate it, but the easiest way to do it, I'm so sorry, you're going to translate this line. And you're going to translate it so this F matches up with that H perfectly. Easiest way to do that is translate this by the point F. Oh, you have to click the actual line. I hate this. That did not work. Translate by vector. We want to translate this line, make them overlap perfectly. Boom. And then make a line from here to here. Now these lines are perfectly parallel. They would never touch each other if you extended it. Does that make sense, guys? I know I went through it really fast and I kind of did like a little cheat way to do it, but that'll get you able to do this really fast. So that's the hard way of doing it. And I want to get through that because we're out of time. The easy way of doing it is literally just go on here, make a parallel line, click here, there, boom. You have a parallel line. That's all you have to do. All right, guys. So if you guys haven't answered the questions, make sure to answer that. Hopefully that helped you guys out. All right. So I'll see you guys on Tuesday. All right. Bye.